So here we're continuing on with our look at the cross section from like the Pacific Ocean over to the Atlantic Ocean. We had found there was a fault by Ridgecrest, and that was this section right here. Then in the last lesson we saw that there was another fault over here under the Mid-Atlantic Ridge. We identified this big piece of bedrock as being a plate or a tectonic plate. Familiarizing ourselves with the diagram again, we have our bedrock up here, mostly this pinkish purpley color. We have our softer bedrock because it gets warmer as we go deeper. Underneath here we would have our magma. Our new detail to add today is that Mount Mitchell right here is moving 3 centimeters to the west per year. And the west would be going to the left here, since this is California and the Atlantic Ocean. So the west would be over to the left. So it's moving 3 centimeters to the left. Okay. So that's one thing we can add on now. What changes do we see as we go deeper below Mount Mitchell? Well, we know that the rock is getting softer as we get warmer. We can have that creeping going on. Okay, so that's something else we know now. What do we think is happening to the land at Earth's surface many miles to the west, way over here, and many miles east of Mount Mitchell? So it's kind of looking at the other plates that we would come across. Again, here's our fault. So this is another plate. Here's our fault. Here's another plate. So if this is going to the left, going to the west, kind of makes sense that this would also go to the left, this last section over here. And if this is going to the left, it kind of makes sense that this is going to the left. It's a hypothesis, it's a theory. We don't have any data. All we know is that Mount Mitchell is going to the west. But that sounds kind of like a good theory to start with. If this is going left, this is probably going to the left, and so is this section over here. So one way we can find out is to take a look at all of North American plate. So this is just the lower half of the North American plate, and as you can see we have arrows here, and these arrows are where sensors were placed for GPS, and we can see that the plate is moving mostly to the left. There is one spot up here near Seattle it's actually going off to the right, but most of these are going to the left, and they're not all directly left. Like the ones over the Mid-Atlantic Ridge are kind of going up diagonally left. As we get the center of the country, it's mostly to the left, and as we get down here towards California, it's kind of going to the southwest. So it's almost like a sweeping action here. So it's kind of like coming up, going over, and then coming back down. So it's kind of like arcing from the north or the southeast up to the west, and sweeping back down to the southwest. That's this section. You can see the United States right here, so that's the U.S. section right here. If we look at the rest of the plate, so what we just looked at was way down here. And if we look more at the top part of the North American plate, this is all Canada, going up to Greenland, and all the way up kind of closer to the Arctic Circle. So we can again see how it's going up, and kind of going across and then down, going up, across, and then down. So it looks like the plate is not moving directly west. It's kind of like doing a rotation. So it's kind of coming up and over. And so the question is, where would we predict North American plate would be, I don't know, say 10,000 years in the future? If it's moving 3 centimeters per year, and it's 10,000 years, and 3 centimeters, let's call it an inch. It's just a little bit more than that, but let's call it an inch. That would mean it would move 10,000 inches. And 10,000 inches turns out to be about 880 feet, which if you're by our school and you go around the track once, that's about 1,600 feet. So it's about half a lap around the track, 1/2. And that's how much the North American continent would move in 10,000 years. So we're not talking about a lot of distance here. But let's take a look. So where would we predict it will be in, say, 10,000 years? I'm going to switch from this image here. I'm going to show you what I have instead. So this is our North American plate, where North American plate is. Here is Africa, South America, Europe, and Asia. The other side of Asia, Australia. So I have that diagram here, except I have it so that my North American plate is movable. So it's just another piece of paper the same size that's on top. So the idea here is, where would the North American plate be, say, in 10,000 years? Well, if we go with the direction that the arrows were showing us, it's not going to go directly west, because that's not how the arrows are pointing. They were kind of pointing up, over, and down. We don't want it to go down, because it's not just down, it's over. So it's almost like we're going to do a west and south, but that's really not correct either. It's almost got to be like this arc. So we said it was kind of like arcing, so it's almost going to be kind of doing a shift like this, where it's going to kind of go to the side a little bit. Now, it's not going to move that much, because that's a couple hundred miles right there. So this is all the United States right there. And if we move that much, that's like a third of our country. So it's not going to move that much, but just to show you that how it moves, it's going to kind of tip a little bit. So it's going to kind of arc down this way. And we would expect it to be someplace, sort of like that. Maybe not that far, but something to that effect. So we can put these GPS sensors on all the continents, and we can find out what happens with all of the plates. And this shows where all the plates are and how they're moving. You can see that we have yellow, green or blue, and pink or purple arrows. The green are showing where plates are moving away from each other. Purple is showing where plates are kind of going past each other. And yellow, it's hard to tell what yellow does, but we know that North America was moving to the west, so it's kind of going this way. And this yellow arrow is pointing towards that. So it looks like this is when plates are moving towards another plate. So yellow is pushing into another plate, green or blue is pulling away from each plate, and purple is where they're kind of going past each other. If we look at this whole map of all the plates, we can see that most of the areas are blue, where they're going away from each other. The next most common thing would be where they're being pushed towards another plate. And then the most uncommon thing is where their plates are kind of like passing each other. There's really no pattern overall. It's not like we can say everything in the northern hemisphere is doing this, or everything in the eastern hemisphere is doing one thing. There's no pattern here. It's just things are moving around. But we can find out that all the plates are moving. No plates are sitting by themselves and not moving. Everything on the Earth's crust is moving around, and this is all based on GPS data. So our next thing we're going to look at is what's happening in these different areas, and we're going to try to model what happens in those different situations, whether things are being pulled apart, being pushed together, or sliding past each other.